Hello friends, thank you for watching this video. I am Mohamad and today we will be exploring unit of work and repository pattern with EF Core and .NET 5. So what are we going to be covering today? First, we're going to be discussing what is a repository pattern. Then we're going to discuss the benefit and why do you want to use a repository pattern. And then we're going to be discussing unit of work and what is it and the benefit of unit of works. Then we're going to be discussing all of the ingredients that we're going to be needing in order for us to implement it. And lastly, we're going to go into the code. As always, you'll find the source code in the description down below. Please like, share and subscribe if you like this video. It will really help the channel. So, what is a repository pattern? The repository pattern is talked about a lot, especially in the API and microservices heavy world, and the .NET Core shines in. The repository pattern is a strategy for abstracting data access layer. So, what is a data layer? It's made up of code and an application where it's responsible for storing and retrieving data. Adding, removing, updating, and selecting items from this collection is done through a series of straightforward methods, without the need of dealing with the database concerns like connections, command, cursors, and readers. Using this pattern, we will be able to achieve all of this loose coupling and keep the domain object persistent and ignorant. So as we can see here from the two graphs, in the traditional pattern, we can see that all of our different application components like controllers, services, sinks, and initializers, all of them have direct access to our database. So there is no like a middle layer which actually communicates or actually control this communication between our application and the database. It's a direct connection. While in the repository pattern, all of our controllers, initializers, services, and sync directly communicate with the repository, and then it's the repository job to be able to communicate with the database and actually execute those commands, and vice versa. So for example, if we're trying to get some information from the database, it will first go through the repository and then it will be actually sent back to the controllers, for example, if it's requesting it. And if the controller wants something, it will need to communicate with the repo will need to be able to communicate with the database, and then so on and so forth. So the repository will be able to handle all of the incoming and outgoing requests for the database and handle all of these connections instead of having all of this logic embedded within the controllers, initializers, service, and sync. So why do we want to use repository pattern? So there's many reasons why do we want to use repository pattern, but the main ones is, first of all, is reduce code duplication. So basically, repository pattern will allow us to utilize dry design principle, where we will write the code once and we can utilize it everywhere we want in our code. So let's go back to our graph. So as we can see here, if for example a controller want to access, for example, the users table, and a service want to access the users table, so instead of having two logics within the controller and one within the service to handle all of the users table communication, we only have one code which is resided in the repository, where it's actually responsible for handling all of the users tables actions. So the second one is loose coupling. So basically it's a loose coupling to the underlying persistent technology. So in case we need to switch, for example, our database from MS SQL to Postgres or MySQL, only the data layer implementation will need to change. Not everywhere else we are actually consuming it. So this will facilitate the change and update and reduce the chance of errors. So for example, let's say we want to update our database to, let's say, Postgres. All we need to do is actually update the repository instead of actually updating the entire application. And that way we'll be able to actually have one place where we can actually do all of the changes without affecting the rest of our application. So the application is basically clueless of what type of technology that we are using or what type of database we are using, as long as it's getting its information. And that way we can actually do some delegation of the work through to only the repository and actually abstract the application from worrying about how it's going to be connecting to different types of technologies, database technologies. So that's why it's a really good added feature to have loose coupling when it comes to the repository pattern. Now the third point is the stability. Based on the loose coupling, it means that we can actually create some mock database and utilize some mock technology through our repository pattern to test out every single item within our repository or our application. Because from that we can create a mock database, and from that point forward we can create our unit test. And the last point we want to discuss is actually separation of concerns. So what is separation of concerns? Separation of concerns is separating the application functionalities based on a function. So as mentioned earlier, so the reason behind a repository pattern is to have everything related to data access in a single place. So we don't have all of the logic embedded within our application where we have bits and pieces of different functionalities related to the database scattered around our application. So all of the DB logic is saved within our repository pattern, and for any reason we need to update it, all we need to do is update one single place instead of actually going through the application and try to find all of the different layers and then updating them from there, which highly increase the chances of errors, specifically if the code is really scattered around our application. So separation of concerns actually meaning create different components, and every component will actually have one single goal or one single functionality that we can actually utilize. And with this, we're creating a repository libraries, and those repository libraries will only be responsible for data access layer. So the next point we're going to be discussing is unit of work. So what is unit of work? So if repository pattern is our abstraction over the idea of persistent storage, the unit of work pattern is our abstraction over the idea of atomic operation. It will allow us to finally have fully decoupled from our service layer and from our data layer. The unit of work pattern now manages the database states. Once all of the updates of the entities in the scopes are completed, the track changes are played into the database into a transaction, so the database reflects the desired changes. Thus, unit of work pattern tracks a business transaction and translates it into a database transaction, where the steps are collectively run into a single unit. To ensure that the integrity of the data is not compromised, the transactions are committed and rolled back in discretely, thus preventing intermediate state. So as we can see here, from the repository pattern, we have something called the unit of work. So within the repository pattern, we have, for example, here 3 repositories. We have the item ones, the user repository, and the cart repository. And all of these repositories, they don't directly speak with our users table, with the tables itself. So for the items will not directly speak with the item table, the users will not speak directly with the users table, and the car will not speak with the car repository will not speak with the car table. What they do is actually they go through the unit of work, which is actually classes and interfaces which manage the connection to the database. And from that point, all of the work is sent to the unit of work, and the unit of work handle all of these transactions before sending them to the actual database. We will see how we can implement this and what the actual benefit which comes into the implementation of this unit of work. So now, what are the benefits of having unit of work? It's abstracting the data access layer and the business access layer from the application. So if you want to implement, for example, any kind of business logic within our database data access layer, we can actually utilize the unit of work in order for it to have this separation. So we can have the data access layer up on the side, the business layer on the side, and then we can actually utilize them both. Second benefit is actually utilizing the in-memory database. So for example, when we're trying to do adding a lot of users to the database, for example, so instead of having, let's say we have 1,000 users, instead of actually opening 1,000 connection to the database every time we want to save a user and actually having 1,000 calls and verification that our user has been saved correctly, what we can do is within the unit of work is we save those 1,000 users into the memory, and once all of the data is ready and prepared and processed in order for it to be communicated with the database, all we need to do is have one single connection open to the database where we send the commands directly to the database where we are able to save those 1,000 users, and then we can get back the confirmation and to be for our application to resume processing. So basically, instead of having multiple connections simultaneously doing the same thing over and over again, the in-memory database will actually handle all of the incoming transaction, prepare them, store them until it's ready for us to save it in a single request to the database. This is a very simple example of in-memory database, but it shows you the power of in-memory database where we don't actually have to have multiple connections. For example, back to those 1,000 users, instead of having 1,000 connection, which is going to consume a lot of memory resources, a lot of network resources, and might cause our application to slow down because of I/O issues. Those in memory will save us from 1,000 to one call, and this will add a boost to our performance as well to our database health. The third point is dependency injection. So basically, the dependency injection here will allow us to utilize the loose coupling. So we are able to actually inject the unit of work into our constructors or into our classes or anywhere we will use them in our application with dependency injection instead of having us to rewrite all of the code in order for us to communicate with the database. And lastly is the unit test. With dependency injection, we are actually able to write a much more advanced unit test and enable test-driven development in order for us to make sure that we are covering all of the scenarios that we need to cover when it comes to our application and our database structure. So, based on those, what are the ingredients that we're going to be needing in order for us to develop our application today? First, we're going to need Visual Studio Code, and then we're going to be utilizing the .NET 5 SDK. You can find the links on the screen and in the description down below. The installation process is pretty straightforward. All we need to do is just download them and install them. Great. Now let's get started. So after downloading and installing VS Code and the .NET SDK, now we need to make sure that our .NET SDK has been installed successfully. In order for us to do that, we're going to be utilizing the .NET version inside our terminal. So .NET -- version, and as we can see here, I have version 5.0.301, which is the latest version by the time of recording this video. If you have any other number, that should be fine. If you have any error, you need to re-download and install the SDK. Now that we have done that, it's time for us to install the Entity Framework tool, because we're gonna basically utilizing Entity Framework within our application. So we're gonna create a new project using the .NET, we're gonna be installing the tool using the .NET tool keyword. So .NET tool install -- global, because we want it available everywhere on our OS, and .NET -ef, which refers to Entity Framework, and we click on enter. And since I have already installed it before, it's telling me that it has already installed, but if you haven't installed it before, it will take a few seconds to a minute to get downloaded and installed. So after that, we're gonna be creating our web API. So we're gonna be utilizing the .NET new keyword. So .NET new web API -n, and we're gonna call it Pocketbook. Great. This should take a few seconds to be installed. Great. Now that has been installed, let's go to the directory and let's open it in Visual Studio Code. And this should take a few seconds. Great. Now that I have our application open, the first thing we're going to be doing is we're going to be opening our terminal. So we're going to have to go to View, Terminal, and inside the terminal we're going to type .NET build to make sure that application builds successfully, and it does. And then we're going to type .NET run, and we should see the application running. Perfect. And in order for us to make sure it's working, let's first check the controllers. So it's weather forecast, and it's a simple get. So let's take this and let's open our browser, and inside our browser we're gonna go to localhost 5000, and we're gonna be weather forecast. And as we can see, we have the JSON being returned, which means the application is running as it should be. Great. Let's go back to Visual Studio Code and let's stop our application. So once we have done that, the next step for us is we're going to be adding some packages, because we're going to be utilizing SQLite and Entity Framework inside this application. So we need to add the packages for our application for SQLite as well as for Entity Framework. So the first thing we're going to be doing is we're going to add 4 packages, and the first packages is the Entity Framework core tool. So we'll start by .NET add package, and it's going to be Microsoft .ASP.NET Core .identity .entity framework core. So this should take a few seconds. Let's see if it has installed. No, it hasn't. Maybe I typed it wrong. Let's see again. So the next package we're gonna be installing is it's gonna be the SQLite. So .NET add package Microsoft dot entity framework core dot SQLite. This should also take a few seconds. Great. The one after that is the entity framework core tools. So .NET add package Microsoft dot entity framework core dot tools. Perfect. And the one after that it's gonna be the entity framework tool diagnostics. So .NET add packages add package dot Microsoft dot ASP not core dot diagnostics dot entity framework core. Perfect. So now that we have installed these 4 packages, we can verify that they have been installed by going to pocketbook.cs and we can actually see that our 4 packages has been installed successfully, which is the ASP.NET Core Diagnostics, the Entity Framework Core, Identity.Entity Framework Core, Entity Framework Core SQLite, and Entity Framework Core Tools. Perfect. So once we have done that, the next step for us is to open our application settings.json, and we need to add our connection strings, because this is the connection string that our application is going to be utilizing to save our information to our database. And since right now this is a demo application, we're going to be utilizing SQLite. So let's create a new connection string section, and we're going to define the default connection. And since this is SQLite, we're going to be using data source. And it's gonna be, we're gonna call it app.db, and let's give it the cache equal shared. Great. So once we have created our connection string, the next step for us is to actually start by cleaning our application. So the first thing we're gonna be doing is we're gonna be deleting some stuff from the boilerplate code that the application has given us. So we're gonna delete the weather forecast class. We don't really need it anymore. So delete, and we're gonna be deleting this controller as well. Delete. So once we have done that, now let's build our application .NET build, and we need to make sure that it's building successfully. Great, build succeeded. So the next step for us, it will be creating our data directory and our Applicationdb context. So our Applicationdb context is going to be responsible for all of the communication with the database. And the first thing we're going to be doing is we need to create a new folder inside the root application of our the root directory of our application called data, and inside that folder we're going to create the Applicationdb context class. So here we need to create a new folder, and we're going to call it data, and inside this data folder we're going to create a class, and this class is going to be called Applicationdb context. Perfect. So once this class has been created, we're gonna start creating our Applicationdb context. So the first thing we need to do is we need to inherit from the db context class, and this db context class is provided for us from Entity Framework Core. Great. So once we have done that, now we need to initialize it through the constructor, and basically we're just gonna pass the db context options. So how do we do that? Inside the constructor parameters, we're gonna put db context options, and we're gonna take the Applicationdb context, and we're just gonna call it options. And then basically, since we're inheriting from the db context, we need to pass it back. So we're gonna go to base, and we're gonna pass it back to the parent class, and we're gonna pass the options. Great. So this is all we're gonna do right now within the Applicationdb contacts. We're gonna be adding more stuff to it as we go. So after we have created the Applicationdb contacts and we are make sure that it has all of the information that we currently need, the next step is we need to update our startup class and add the Applicationdb contacts to our startup class so we can actually utilize it across our application. So let's open our startup class, and inside our configure services method we're gonna add the following, which allow us to utilize the Applicationdb contacts that we have. So first thing is we're gonna be calling the services because it's part of the service collection, and then we're gonna add db contacts, and then we're gonna pass the Applicationdb contacts that we have created. So application db contacts, and let's fix the references. Great. So once we have add this, now we need to add some options, because as you remember in the constructor we have passed some options, so we need to specify these options. And basically the options are gonna be, first, what type of database we were gonna utilize. So we're gonna be utilizing SQLite, so we're gonna say options dot use SQLite, and we need to fix the references for this. And once we have done this, the next step is we need to specify the connection string of where this is gonna be able to find the SQLite database. And in order for us to specify it, we need to open brackets, and inside it we're gonna put configuration dot get connection string, and we're just gonna pass it the default connection that we defined earlier. So it's gonna be default connection, and after that, that's it. So just for reference, the default connection that we have here is the same default connection that we have added here inside the application settings. And here, let's make sure it's the same. Perfect. And this Applicationdb contacts is the same class that we have created inside the data folder here. Great. So once we have done that, the next step we're going to be doing is we're going to be creating our models folder. And inside our models folder, we're going to be creating our first entity, which is going to be the user's entity. So inside the root directory, we create a new folder called models. And inside this models folder, we're going to create a new class, and this class is going to called user. And basically right now we're going to build a simple API which is going to give us back some user information, and we're going to allow us to basically do all of the CRUD operations to that user entity, utilizing the API and utilizing the repository pattern and unit of work. So once we have created a new class, now let's fill this class. So the first thing we're going to be doing is we're going to be specifying this user's ID. So prop GUID, it's going to be ID, and since this is a GUID, we need to add the using system. So let's add it, using system. Great. And then we're going to basically just have the first name, last name, and email. So prop string first name, prop string last name, and lastly it's gonna be the email, prop string email. Great. So once we have done that, now we need to add this user to our Applicationdb contacts, because right now we have created the model, but we need to reflect this model into our database, and currently there is no way for us to do that. So let's copy this, and inside the Applicationdb contacts we need to add this entity. So how do we add that? It's very simple. We're going to be utilizing dbsets. So it's going to be public virtual dbset. We're going to pass the user class, and we're going to call the table users, and basically here we're just going to specify the getters and the setters. And basically here we're utilizing the entity framework code first approach to create our database and utilizing it. If you want more information about the entity framework and the code first approach, I have another video which I delve deep into that, which I'm gonna be linking here on the upper right hand corner. Great. So once we have added this, let's add a comment here so we can explain what's going on. So the dbset property will tell EF, which is entity framework core, that we have a table that needs to be created if it doesn't exist. Great. So once we have done that, now what we're gonna be doing is we're gonna be creating this actual database and creating this table inside this database. So how do we do that? So we're gonna be utilizing some entity framework tools that we have installed earlier, and basically from inside our terminal we're gonna do two commands, which basically first we're just gonna be set up, prepare all of the required setup for the database, and second is gonna be executing that setup. So the first command we're gonna be utilizing is .NET Migration. So we're gonna put .NET, which is basically referring to .NET SDK, EF, which is referring to entity framework, and here we are actually utilizing the tool that we have installed earlier, and now we are adding the command, which is migration. So we're telling entity framework to create a new migration, which basically new SQL script that's gonna be applied against our database, and then we're gonna put the word add because we're creating one, and we're gonna give it a message, which basically what changed inside this migration. And right now we're just gonna do this is initial migration because we don't have a database, we don't have anything, so it's gonna be the initial migration. And as well we're gonna say adding the user class, the user table. Great. So once we have done that, we click on enter, and just to take a few seconds, and let's monitor here what's happening. We're gonna see right now a new folder popping up, which is called migrations. And if we open this migration folder, we can see here that we have three things, sorry. We have some numbers and then initial migration with the message that we have added. As well, we have something called the Applicationdb context model snapshot. So the Applicationdb context model snapshot basically represent a copy of what information exists in the database. So it will give it will have information about which table does it exist, does it contain, what are the rows and the fields of every table. It's just like a schema of that database is saved inside the Applicationdb context model snapshot. Basically all of the schemas are saved here, because every time we create a migration, a comparison will happen between the Applicationdb context model snapshot as well as the changes that we have made. And the difference between these two schemas are basically the migration scripts that's being created in order for us to update the database to the latest version of the changes that we want. So here, if we open this, we can see right now all of the changes that we wanted to do, which is basically here we can see that we have a new table called user, and basically it has ID, which is of type text, email, first name and last name. And we can see here that it has the command of create table, and it gave it the name users, and we can see here that the ID is of type GUID, first name, last name, and email of type string, and everything is nullable except the ID, which is what we expect, as well as it specified the primary key, which is going to be the ID, because entity framework will automatically take the ID keyword of every properties as a primary key. Great. So once we have done that, now the next step for us is to actually create the database and actually apply this migration. So because we don't have a database, Entity Framework is going to create it automatically for us and apply all of these changes for it. So let's monitor what's going to happen here. First, inside our terminal, we're going to type .NET EF database update, and this keyword basically, the .NET refers to .NET SDK, Entity Framework refers to the Entity Framework tool. We're specifying we're telling the Entity Framework that we have a command for the database, and the word update means that we want to apply all of the changes that the migration has created. If there is no migration will be updated. So let's click on enter and let's monitor what's happening here. So this should take up to a minute, and now we can see that we have a new database created, which is called app.db, and we're gonna open this app.db and check what's inside. So in order for us to do that, we're gonna be utilizing dbbeaver, which is a free tool that will allow us to utilize and view the database. So now we're gonna click on this icon here, and we're gonna be utilizing SQLite. So we select it and click on next, and then we're just gonna browse to it. So we're gonna go to desktop, YouTube, Pocketbook, and AppDB context. We're gonna open this, test connections, make sure it's okay, and click on finish. And once that, we can see that our application is here. And once we open it and we go to tables, we can see that we have the tables user that we have created. And if we open this by view data and we go to properties, we can see the 4 properties that we have, which is ID, first name, last name, and email. Great. So let's go back now to our application. And we're gonna be starting right now by creating our repository. So inside the root directory of our application, let us create a new folder called core. And inside this folder, we're gonna create another folder which is called iRepositories. And inside the app repository, we're gonna create our first interface. And this interface is gonna be the most generic interface that we're gonna be utilizing in order for us all other interfaces are gonna inherit from. So we're gonna create generic repository, and we're gonna be clicking enter. And now we have an interface inside the iRepository and inside the core folder. So basically what we're going to be doing is we're going to be creating generic repositories, and then we're going to be creating specific repository which is going to be inheriting from the generic repository. That way we're going to have the same commands available for every repository, and if there's any repository that's going to have its own unique command, it can add it independently instead of having it across all. And this way where I can actually utilize and have the dry model there, so we can create the code once and we can utilize it everywhere. So once we have added the interface, now we're gonna start building it. So the first thing we're gonna be doing is, because we're gonna make it generic, we need to add the T keyword, and we're gonna say where T is a class. Perfect. And once we have done that, we're gonna specify that the 6 methods that we want. It's gonna be, first of all, task, because it's gonna be an asynchronous request, and we're gonna utilize the enumerable, and then we're gonna return a list of T based on the class, and it's gonna be called all. Now let's fix those references. Perfect. So the next one we're gonna say it's get by ID, so task, and we're gonna return T, and it's gonna go get by ID. And right now it's gonna be the ID of type GUID. And here let's use system. Great. Next we're gonna doing the add, which is gonna return a boolean, so task bool add, and it's gonna take basically the type T. Then we're gonna add task for the delete. Sorry, we're gonna return a boolean, and it's gonna be delete, and it's gonna take the GUID ID. And then we're gonna do the upsert, which is gonna be task bool, and we're just gonna do the upsert, and it's gonna take T, and then we're gonna call it entity. Perfect. So now we have these 5 methods that we're gonna be utilizing, and this is, as we said, this is gonna be the generic repo. Now we need to create the specific repo for the users. So how do we do that? Inside the iRepository, we create another interface, and this interface we're gonna call it iUser repository. So once we have created this iUser repository, we're gonna be utilizing the iGeneric repository. So how do we do that? If you said inheritance, that's correct. So we come here and we're gonna inherit the iGeneric repository, and we're gonna pass the user's entity to it. And that way the user here is gonna replace the T model here whenever we're gonna be utilizing this generic repository. Great. So as I said here, these are all of the methods that are going to be utilizing all across all the repositories. So let's say we have a car repository. will inherit this iGeneric repository. As well, we can add different types of methods related to the car inside the car repository. So right now, for example, let's say I want to get the first name and last name of the user, and we have let's say we have the car repository and we have the iUser repository. It does not really make sense to add here the method of get first name and last name of the user, because the car does not have a first name and the last name. So it does make sense actually to add it in the iUser repository. So in case I want to add that, all I need to do is here tasks, and I can return a string, for example, and here it's gonna make get first name and last name, for example, and it's gonna take a good ID. And basically right now I created a new method, a generic method, a specialized method for a user repository, which is not going to be available for anywhere else. Whereas every method in the iGeneric is going to be available for every interface or any repository that's inherited from it. Okay, great. So now that we have covered those, so we don't really need that method right now, but once we have created the iUser repository, now it's time for us to create the iUnit of work, which is basically the interface for the unit of work that we're going to be utilizing. And inside the core folder, we're going to be creating a new folder, which is going to be calling it the iConfiguration. And I think you can tell right now that everything that we do within the unit of work pattern as well as the repository pattern is all based on inheritance and interface and classes. So once we have created the iConfiguration folder, we're gonna actually create the iUnit of work interface inside of that. So let's create a new interface and we're gonna call it the iUnit of work. Great. So once we have created the iUnit of work, and this interface basically is gonna have all of the repository that we're gonna utilize. So right now, since we only have one repository, which is called the user repository, iUser repository, so we have to add this here. As well, we're gonna add another method called complete async, which is gonna be responsible of communicating all of the changes that we added to our entity framework and repository to the database. So first, we're gonna just add the first repo, which is iUser interface. iUser repository, and we're just gonna call it users, and we're gonna specify the getter for it here, and let us define fixed references, and then we're just gonna create a task for a method called complete async, and this complete async is gonna be responsible for actually sending the changes back to the database. Great, so let's fix this. So now that we have created or started to create the skeleton for our unit of work, now it's actually time to start doing some of the work for the actually filling the repository's work. So how do we do that? So we need to create a repository folder inside the core folder. So as you see here, we have the interfaces. Now we need to create the actual implementations for it. So inside the core folder, we create a new folder. We'll call it repositories. Sorry, not a file, a folder. Let's copy this and let's delete this. And yes, move to trash, thank you. And here, new folder, and just paste it. Perfect. So inside the folder here, we're gonna be creating that generic repository. So we're gonna create a new class, and this class is gonna be the generic repository implementation. Okay, great. And as we did for the iGeneric repository, we need to make it also generic. So how do we do that? We're doing the same thing. So let's go here and let's first add the T to make it generic, and then basically what we're going to be doing is we're going to be inheriting from the iGeneric repository, so we can enforce all of the methods that we have inside the iGeneric repository, and we're going to pass the T because it's also generic, and we're going to specify that the T is a class. And now let's fix these references. Great. So once we have added that, we still have the squiggly line here because we have not implemented all of the methods that this repository requires. So we're gonna start by doing that. The first thing we're gonna be doing is we are gonna actually adding the Applicationdb context. So from here it's gonna be protected, and it's gonna be the Applicationdb context because we're gonna be utilizing it, and just we're gonna call it context. And let's fix these references. Great. So the next thing is we're gonna make it internal, or we're gonna make it protected, doesn't matter here. And because it's a dummy application, we're gonna call the dbset t, and we're gonna call it dbset. Also, let's fix these references. And lastly, let's add a logger. So let's also make it protected, and make it read only, make it ilogger as logger. And let's fix these references. Perfect. So once we have done that, now we need to start initializing it by initializing the constructor. So first we're gonna be initializing the Applicationdb context, and it's gonna be underscore context, and then we're gonna be initializing the logger. So logger, and then basically it's gonna be underscore context equal context. We're just doing all of the required setups for the dependency injection for it to work, because right now the Applicationdb context is added to our dependency injection because we have automatically wired it up inside our startup class with this. Because we have added here the add.db context, it will be available for us inside our, let's undo this. Yeah, so it will be available for us inside our dependency injection framework, so we don't really have to do anything else. So, and this is how actually we are able to inject it through the class that we are currently utilizing through dependency injection. So we have already added the context, and the logger is automatically provided for us by the entity framework, by the ASP.NET Core. So now we're just gonna be utilizing it logger, and let's save this. And now let's click on here, and let's click on implement interface. And as we can see, we have the five methods has automatically been created for us, and we can actually utilize them. So the first one we're gonna be doing is the get by ID. So we don't really need that. Let's delete it, and basically we're gonna just do return await dbset dot find async by ID. So that's the generic repository, but we're gonna be able to change it later. And here we're gonna make it async because we're utilizing await. And the next step, we're gonna be utilizing the add, and also let's add the async from now. Let's delete this, we don't really need it. And now let's actually add the functionality, which is gonna be await dbset dot add async, and it's gonna be entity. Save, and then we're gonna put return true because it has to return a true, a boolean, sorry. So once we have done that, now let's do the delete. What we can do actually, so we can see how it's working, we're gonna just leave it as not implemented, so we see if actually we don't implement it, what's gonna happen. The upsert, we're gonna do the same thing, and for the all, we're just gonna return everything. So what we're gonna be doing is return, let's here make it async, and we're gonna make it dbset dot to list async, and basically we're gonna be returning everything, and we need to await it. Great. So once we have done that, and we have created the generic repository, now for us, let us continue by rebuilding the user repository that we have added. So we have added here the iUser repository. Now we need to add the user repository here. So we're gonna create a new class, and this clue class is gonna be called user repository. Great. And this user repository is gonna follow the same structure as the generic repository, but instead of inheriting directly from the iGeneric repo, we're gonna inherit from the generic repo and then from the iUser repository, so we can have both of them here. So user repository, we're gonna inherit from the generic repository. We're gonna specify that's gonna be of type user, and we're gonna also inherit directly from the iUser repository. In case we have extra method that is not part of the generic repository, the iUser repository will be provided for us. So let's fix these references. Now we're having issues. Okay, so once we have added that, we actually need to implement this. So the first thing we're gonna be doing is we're gonna creating the constructor, and inside the constructor we're gonna be initializing the DB context. So we're gonna be passing it back to the parent class, which is the generic repository, and basically we're gonna be doing something like this: application DB context. Let's fix this reference, and the logger. So logger, and let's fix this. And from here, basically, because we're inheriting from the generic repo, we need to pass it back to the base, and we're gonna pass the context and the logger. Great. So once we have done that, we can now actually start implementing some of the methods that we want, and we're gonna be basically implementing the all, upsert, as well as the delete. Because the add is very simple, we don't really need to override it. So let's start first by the all. And how are we gonna do that? We're just gonna be making it public, and because this method already exists in the parent one in the generic repo, we're gonna override it. So we're gonna utilize the override keyword, and we're gonna be utilizing the async because it's gonna be async method, and basically we're gonna be return a task of I enumerable, and it's gonna be, we're gonna return a list basically of users, and we're gonna call it all. If I can type they. Okay, great. Now let's fix these references. So once we have done that, the next step for us is to create a try catch. So in case something goes wrong, we are able to do graceful error handling. And let's fix this. And basically here all we're gonna be doing is return await dbsat dot to list async. And in case something goes wrong, we're gonna just add it to the logger. So we're gonna say logger dot log error, and basically we're gonna pass the exception, and then we're gonna build a message. We're gonna call it here repo because we're gonna pass it, and then we're gonna say which function, which is all method error, and then here we're just gonna pass the class name, and we're gonna be testing the type of. Oh, apologies, this should not be here. Yes. So this should be type of, and we're gonna make it type of user repository. Great. So the next step is, because it has failed, we're gonna return an empty list. So we're gonna put return new list of users, which is gonna be empty. Okay, perfect. Still telling us that we have an error. I wonder why. So return a list await async. Let's see what's the error. Cannot override inherited member. Okay, let's go back to the generic one, and we forgot to add the word virtual because we want to enable overridden. So this is gonna be virtual. Okay, great. Let's save this and let's go back here, and it's not complaining anymore. Perfect. So once we have done that, the next one we're gonna be is updating is the upsert. So public override async. It's gonna be a task and it's gonna return a bool, and it's gonna be upsert and the user entity, and basically we're gonna look for this user based on its ID. If we find it, we're gonna update it. If we don't, we're gonna add it. So var is it gonna be an existing entity, existing user equal await dbsat.where. We're gonna adding here the conditioning for this, so we're gonna be utilizing where, which is gonna be based on link, and then from here we're gonna add the condition x dot id is gonna be equal to entity.id, and then we're just gonna get the first or default, so dot first or default async, and then that's it. So right now we're actually going to the database, checking if there's an ID which matches the ID that the entity has, and we're returning the first result. If it's not, we're returning a null. So now we're gonna actually do the check if existing user equal to null. So it means it doesn't exist, the ID and the user does not exist. We're gonna be adding this information to our database, not updating it. So we're gonna put return, we're gonna call the add method, and we're gonna pass the entity to it. Great. But in case it actually exists, we'll just need to update it. So we're gonna put existing user dot first name equal entity dot first name. It's gonna be existing user dot last name equal entity dot last name, and then lastly it's gonna be existing user dot email equal entity dot email, and then we're gonna put return to true. Perfect. Now that we have done that, we forgot to put it inside a try catch, so let's do this now. Actually, yeah, let's put it this now, and then so try catch, and as we did before, it's gonna take an exception ex, and basically it's gonna be the same thing as the add. So let's take this and we can adjust it here. So instead of all, it's gonna be upsert, and here it's gonna return false in case it fails. And let's take all of this code here and let's put it inside the try. Okay. I wish Visual Studio Code has better code indentation for C#. Anyways, so once we have added the upsert, now we're gonna add the delete functionality. So after this method here, we're gonna add the delete, and similar to what we did before, it's gonna be public. We're gonna override it, and it's gonna be async, and we're gonna be returning a task of bool, and it's gonna be delete, and we're gonna pass the ID as a quid. The first thing we're gonna be doing is add the try catch. Let's copy this and let's paste this here, and here instead of upsert it's gonna be delete, and that should be the same. And now let's implement the delete functionality. So basically the delete functionality is gonna be the same thing as the first part of the upsert. So var if it exists equal await dbsat dot where, and then we're gonna be matching based on the ID. And then once we have done that, we're just gonna do the first or default, and based on that, now we're gonna check if it exists. We're gonna delete it. So how do we do that? We're gonna just put dbsat dot remove, and we're gonna pass the exists. and here we need to make it not equal to null. And then let's add brackets so we can add the conditionings as well to return true, and we can put return true. But if it doesn't exist, we're just gonna return false. So we're gonna put return false. So basically here we're checking if the actual entity exists based on the ID. If it does, which is mean this is not null, we're gonna remove it and then we're gonna return true. If it is if it doesn't exist, we're just gonna return false. Perfect. So the next step after that is basically now we need to link the a unit of work interface that we have created before with the unit of work and do all of the pipelining and all of the wiring for the unit of work and the repository framework to work simultaneously together. So in order for us to do that, we're gonna create a new class inside the data folder, and we're gonna call this unit of work. Great. So once we have created this unit of work class, the first thing we're gonna be doing is we're gonna be inheriting directly from the unit of work interface, so we can see all of the available all of the available repository that we can utilize. And then we're gonna be also utilizing the iDisposable interface, so we can actually dispose of our DB contacts safely. So using system, and here we're gonna fix those references. Great. So the first step is we're gonna be defining the contacts and the logger. So let's make it private. I think it's better. And let's make it read only. And we're gonna put the Applicationdb context. And again, we're gonna inject this because we're utilizing the dependency injection. And then similar private. It's gonna be read only, and it's gonna be the iLogger. And then once we have done that, let's fix these references. And now we're gonna be utilizing the only repository that we have. So it's gonna be public iUser repository, and then we're gonna call it users, similar to what we did inside the unit of work. And basically we're just gonna put the get and the private set, which we can actually utilize. We can actually update to use the init only setters that C#9 provide, but for now we're gonna keep it as private set. Let's fix these references. So once we have done that, we're gonna be initializing the constructor now. So, and first of all, we're gonna pass the Applicationdb context, and it's gonna pass the iLogger factory, because from the iLogger factory we can create a logger. Great. And now let's initialize them inside the constructor. So as we said before, context equal context, all thanks to the dependency injection and its magic, and then logger equal logger factory dot create logger, and we're gonna call it logs. Perfect. Once we have done that, now we need to do the wiring between this interface, the iUser repository interface and the user repository that we have created here. So how do we do that? It's very simple. We're just gonna put users, which is basically referring to the iUser repository interface, equal new user repo, and we're gonna pass the required context and the logger. and let's fix this reference. Great. So now we have initialized the repository, we have linked the interface with the actual class, and after that we need to add the other method that we have added, which is the complete async. So we're gonna put public async, and it's gonna be of type task, because we're not gonna return anything from it, and this is gonna be complete async. And now let's fix this reference here. And here all we're gonna do is we're gonna add one command to the database, which is gonna be the save changes. And this save changes is gonna take everything that we have already done inside our in-memory database, and all of the changes that we have done, and it's gonna actually reflect it inside the database. So save changes async. And the last method that we're going to be having here is the dispose method, and we're going to be accessing it through the iDisposable. So it's going to be public void dispose, and basically this method's only going to be disposing of the context, so context.dispose async, and that's it. So basically whenever we're not using it anymore, it will be disposed properly from the garbage collector. Great. So let's do it. Let's make this async, and instead of void, let's make it a task. So perfect. Let's see here. Oh, we need to also implement the non-async one. Let's remove the async one for now. We can manage it later. Okay, great. So once we have done that, now what we need to do is, let's do a quick summary first, then we can discuss what do we need to do. So what we did first is we have created the folder core, and inside the core we have created the iRepository folder, which is gonna contain all of the repository. We have created the iGeneric repository, which contain the main methods that's going to be available for all of the repositories, and right now we only have one. So if you only have one, you don't really need to do that, but because we're going to have a lot of different repositories in future projects, so for now we just had added one. So we have created the iGeneric repositories, and then we have added the iUser repository, and we have inherited from the iGeneric one. And then we have built the iConfiguration, which basically tells define of how the unit of work is gonna behave, and said we only have one repo inside this unit of work called users, and we have added this task which can be responsible for communicating the changes to the database. And then we have added the repositories, which actually are the implementation of the interfaces. And basically what we did is we have initialized the DB contacts and the loggers, and we basically did the implementation for them in the generic one, and then we have override them inside the repositories, user repositories, so we can make them more customized to the actual user's table. And once we have done that, inside the data folder we have created the unit of work, which inherits from the iUnit of work interface that we have created earlier, and the iDisposable, in order for us to utilize the garbage collector to clean our DB context. Once we have done that, we have initialized the DB contacts and the loggers, and then we have defined the repositories that we have, which is the user repo inside our constructor. We have initialized the DB contacts and the logger, and then we can actually initialize the custom user repository that we have created within, and then we injected to them the application DB context and the logger. And lastly, what we did is we have added the code so we can update all of the changes that we do in the memory to the database, and actually disposed of the contacts properly using the context.dispose. Great. So once we have done that, now the application, with all of this work, the application still doesn't know what to do with it because we have not added to the startup class. So the next step is for us to inject all of these changes inside the startup class. So inside the startup class, what we need to do is, inside the configure services method, we're going to add the following. So services dot add scoped, and basically we're going to be using a unit of work and unit of work, And basically what we're doing is we are enable dependency injection of the unit of work to anywhere inside our application. So in case we need to utilize it anywhere, we are adding a scope version of this unit of work, so it will be available within the DI container. Great. So this is the step. So here we just set a command adding the unit of work to the DI, which is dependency injection container. Great. Once we have done that, the next step for us is just to create our controller. So inside our controllers folder, we're gonna create a new class, and this class is gonna be called users controller. Very simple. Users controller. And inside this users controller, we're gonna actually start defining our controller. So it's gonna be also very simple. So the first thing we're gonna be doing is we're gonna be adding some attributes to this class, so we can make it an API class. So how do we do that? The first one is gonna be API controller. The next one is gonna be basically the route for it. And basically we're just gonna utilize the controller's name. Let's fix this. Let's see this. We don't need this components. We don't need the components. We need the other one. Okay. So once we have done that, now what we need to do is we need to inherit from the controller base, which is gonna give it all of the minimum requirement to be an API controller. So we have done that. The next step for us is to initialize the logger and the unit of work. So first of all, we need to declare them. So private, gonna make it only the iLogger for this class, and we're gonna call it logger, and then a private read only unit of work, and it's gonna be underscore unit of work, and let's make this here, fix this references. Okay, great. Once we have done that, now let's define the constructor. So we're gonna first define the iLogger of users controller, and it's gonna be a simple logger, and then the unit of work is gonna be unit of work. And then basically after that we're gonna be defining them, so linking them. So logger equal logger, and underscore unit of work equal unit of work. So before we do anything else, let us build this application, make sure everything is still building. So .NET build, and this should take a few seconds. Great, the building is still building successfully. So the first thing we're gonna be doing is we're gonna be adding the ability to create a user, because we want to create stuff before we are able to see them. So for this reason, we're gonna start by the create, and since this is gonna be a CRUD, we're gonna create the all, create, edit, and delete. So the first thing is gonna be creating a user, which is gonna be an HTTP post. So we add the attribute HTTP post, and then once we have done that, we're gonna add it, make it public, async task of action result. We're gonna call it create user, and all it's gonna take is user for now. There is way better ways to do it, which is gonna create a DTO, but this can be for later video. For now, we just wanna test if the functionality is working or not. So let's fix these references. Perfect. So once we have done that, first we need to check if the model state is valid. So model state dot is valid. And the model state means if the model that we are currently utilizing is a valid model. So if we added any conditions to the model, for example, let's go to users, and for example for the email, if we added, for example, an attribute saying an email, this field needs to be an email. It doesn't need to be only a string. So for now, if I pass an object, for example, it's gonna be for example, any string, it will pass because it doesn't have email verification. But if I add that attribute email, and if I add any string on the object and I send it, it will fail because doesn't match. So that's why we use model state.isValid. So next, we're just gonna generate an ID for the user. So user.id. As you remember, the ID is a GUID, so we're gonna be utilizing the GUID.new GUID, and we need to fix the references for the GUID. And then once that is done, we can see here right now the power of unit of work. So all we need to do is await unit of work.users.add, and we're gonna add the user. And now we need to commit the changes, because the first one adds it into the server's memory, the second one actually sends the changes to the database. So it's gonna be complete async, and that's it. So basically right now we only have 2 lines of code which actually gonna do all of the database work. So let's now continue this. So in case this successfully, we need to follow the REST API right implementation. So we need to follow the created@action, and we're gonna go to the get item. It's not there yet, we're gonna create it, and we're gonna pass the objects for it. It's gonna be the user ID, and we're gonna pass the model of user. So again, this doesn't exist yet, we're gonna create it afterwards. And then lastly, in case something goes wrong, we're just gonna be returning a JSON result of something is wrong. And let's fix this reference. Return JSON. Oh, sorry, I forgot that word new. And let's add a HTTP status code of 500, so the user will be able to know that something has went wrong. And let's put a semicolon. Okay, great. So this is for the created user. Let us try it out. So let's build it first. .NET build. Perfect. Now that has built successfully, let's run it. .NET run. Great. Now we're gonna be utilizing Insomnia in order for us to test all of these. So let's open Insomnia. So inside Insomnia, let's create a new request collection. We're gonna call it Pocket Book V2. And then basically we're gonna be creating a new request, and this request we're gonna make it called create user, and then we're gonna make it a post, and then we're gonna click on create. And now we need to pass the domain, which is gonna be, let's use this one. This is the HTTPS, that's fine. And basically right now we need to pass the body, and as we said, it's gonna take user, so first name, last name, and email. But because we don't want to pass the ID, because we're gonna generate it, we're gonna just pass those. So inside body here we need to choose JSON, and let's fill it up. So it's gonna be first name, let's make it as Mohamad, last name is gonna be Lawand, and email is gonna be Mohamad@email.com. And now let's send this and see what happens. So we got a 404. Oh, because I didn't specify the root, I apologize for that. So it should be users. Let's send it again, and we said okay, we have an error. Let's see what's the error so we can fix it. So it says on the Object reference not set. Okay. On the add on line 38, generic repositories line 38. Let's see what's the issue. Okay, so let us debug it. So let's go back to the user controller. Let's put a breaking point here, and let's stop this, and let's use the debugger inside Visual Studio Code. Okay, great. Now let's go back to Insomnia and let's send this request again, and we should receive it here. Great. So let's jump in, see first if the information are coming through. So Mohamad Lawan. Okay, great. Now the ID should be automatically generated for us. Let's see this one. Great. Unit of work user add. Great. And now it's failing. Okay, let's send it again and see what's happening. Send. And now let's go inside this. So it's going here. The entity is being pulled successfully. Users, great. And it's failing. Okay, so the issue is we forgot to initialize the DB set inside our constructor. I apologize for that. So how do we initialize it? It should be very easy. So it's gonna be DB set equal context dot set to t, which is basically we're setting the context to no matter what class it is. And that's it. Now let's try it again. I think I'm confident enough to write without the debugger, so let's try it. Great. Now let's go to Insomnia and let's send the request. I do apologize for this. So the issue was here. The first of all, we did the wrong referencing, so it should be underscore context then equal to context the one initializing, and that second we didn't initialize the DB set. I forgot to initialize it when I was doing the generic repo, so we just needed to add that DB set equal context to set to t. So that should be it. And now if we try it, it will fail, because if we go back to the user repository, we're actually referring back to a new to the user controllers. We are referring back to this action which doesn't exist set. So let's create this action. So after this, we're gonna create a new method. It's gonna be get http get, and it's gonna take an ID. And then we're gonna put public async task of action result, and we're gonna call it get item, and it's basically gonna take the GUID as an ID. Great. So what are we gonna do? It's very simple. Var, we're gonna utilize the unit of work. We're gonna call it user equal await underscore unit of work dot users dot get by ID, and we're gonna pass this ID. And if user equal null, we're gonna return a not found, which is basically gonna return a 404 status code. And then basically if it is there, we're just gonna return an OK with the result. Okay, let's run it again. So let's go back to terminal, and let's do a cleanup first. .that clean and .not run. Perfect. Now let's go back to Insomnia, and let's call this, for example, Mickey Mouse. Let's call this Mickey, at email.com, and let's send this. And we can actually see that we got the 201 status code created. We got the ID, the first name, last name, and the email. Perfect. So now once we have done that, now let's create a new request, which is gonna be basically get user by ID, and create it. We're gonna take the same thing. Let's take this URL, let's paste it here, and basically after that we're just gonna be passing it the ID. So /. So let's take this ID to test it out, and there's nobody, there's no anything. I was just gonna send it, and we're getting the information correctly with a status code of 200. Perfect. Now let's change one of these numbers to 1 from to 2. We should get a 404. Perfect. 404 not found. If I change it back to 1, send a 200. Okay, great. So now we have the get users and the create user. Now let's see get all users. So the get all users is going to be also very simple. It's going to be a HTTP get public async task action result, and we're just going to be a get, a simple get, and basically we're going to be utilizing var users equal unit of work dot users dot all. That's all we're gonna be doing. I'm just gonna be returning that back to the user. So I'm gonna be returning okay and users. Perfect. So let's stop this application and let's run it again. Once we have done that, let's go back to Insomnia and let's create a new request. We're gonna call it get all users. It's also gonna be a get, so create. Let's take the same domain. Don't really need that ID because we're getting all of the users. And now let's send it. And we can see we got the two IDs that we have, the two users that we have, Mohamad and Mickey. Perfect. So now we have get all, and the create. So we still have two to implement, which is the delete and the update. Let's start with the update first. So let's go back here. So the update, because we're going to be changing something to the database, it's going to be of type post. So HTTP post, and because we need to verify the ID that we're going to be sending it, so in the extra level of security, we're going to adding ID. And then from here we're gonna put public async task action result update item. We're gonna call it, and we're gonna take a GUID, which is an ID coming from the URL, and we're gonna be passing the user's information. Great. And what we're gonna be doing is the first check if the ID is not equal to the user.id. We're gonna refuse this, so we're gonna return a bad request. If it actually matches, we're gonna do await underscore unit of work dot users dot upsert user await underscore unit of work dot complete async. And after that we're just gonna be returning, because it's an update or a patch, we're gonna put a return no content. We're not gonna return anything back, because basically this is the REST standard if we're doing any updates. So let's try this out. Let's stop this, let's run this. So let's create a new request. We're gonna calling this upsert user. So get okay, we're gonna make it a post, so the body is gonna be JSON. Let's take the same one from here, we can just add it, and let's paste it, and let's take this ID and let's add it as well. So let's take this and let's put it here. So we need the URL with the ID, and this ID needs to match this ID. Okay, now let's change the information from Mickey1, Mickey Mouse 1, and the Mickey1 email. Let's see if it's gonna update. Click on send, and we got a 204 no content, which means it got updated successfully. Now if I click on all users and I click on send, we should get Mickey1, Mouse 1, and Mickey1 at email, and we got it perfectly. So now we have the update working as it should. Lastly, we're gonna be adding the delete. Let's stop the application. So now let's implement the delete. So because it's a delete, we're gonna implement the HTTP delete attribute, and we're gonna pass the ID, and then we're gonna be adding public async. If I can type async task action result delete item. Make it as good ID. Great. We're gonna make var item equal await underscore unit of work dot users dot get by ID, and we're gonna pass the ID. So in case this item exists, so our user exists, so if item equal null, basically we're gonna return that this is a bad request because it doesn't exist. And because in case it doesn't exist, we're gonna delete it. So how are we gonna do that? We're gonna utilize unit of work. So await unit of works users delete is gonna take the ID. Then we need to commit the changes to the database. Unit of work complete async, and lastly we're just gonna return the object. So return okay, and we're gonna return the ID. Save, and let's try it out. So let's stop the application and let's run it again. Let's create a new request. So new request, we're gonna call it delete user, and it's gonna be of type delete. Create, well, let's get the domain, so we're gonna make it this, and let's put this here, and we need to add the ID. So let's get all users, and let's get the ID of Mickey, and let's add it here. And now let's see if this will work. So send, and as you can see, we got back the ID. We shouldn't get back the ID, we should return the U item. Okay, let's stop it and let's run it again. Let's go back to Insomnia. Let's create a new user, and we'll call this one, for example, Donald. Okay, duck, and let's call it Donald. Okay, let's create this and get all users. We should see Donald here. Great. Now let's take this, copy. Now let's do the delete and add it here, and now we should see the information of Donald here all available instead of the only ID. Send. Perfect. Now we see the ID, first name, last name, and email. Great. So let's do a quick summary. So what we did first is we created the core folder with the I generic repository. Then we created the user repository where we defined all of the methods that we have. Then we added the configuration inside the add unit of work. Then after that, we have started building the repository inside the repositories folder. Once we have done that, we have added the unit of work inside the data folder. And then we configured them here. We have added all of the mappings together. Once that was done, we updated the startup class so it will take full advantage of the unit of work, and we'll be able to utilize the dependency injection container, and so we can inject it inside our controllers. Then we have created the controllers and we implemented the CRUD on the users. So that's a very simple approach to unit of work. There's a lot of more details that we can jump into. Please feel free to ask any question in the comments down below, as well as any other topics that you'd like me to cover. One thing I would like to mention before I go, so here inside the user's controller for the upsert, it shouldn't be a post here, it should be a HTTP patch. So that's the the correct attribute that we need to utilize in HTTP post. So other than that, thanks again for watching. Please like, share and subscribe if you like this video. It will really help the channel, and have a great day.